Last night, I was sleeping peacefully on my bed, dreaming about chilling out with my homies, when suddenly, a thought struck me that woke the heck out of me. It said, "What is at the edge of the universe?"
What do you plan to do at the edge of the universe, Samuel, when you don't even leave the edge of your house?
Anyways, let's look into it. What is really at the edge of the universe? I mean, could we really go there? Our story begins with the observable universe, the part we can see, because the universe is unimaginably massive in size. There is obviously a limit to what we can see, which we call the observable universe, whose span is 94 billion light years. Because the farthest we could see looking at one single point is 47 billion light years. So it brings out the figure of 94 when multiplied twice. Imagine it as a vast ocean of galaxies, clusters, and superclusters. But here's the catch. The farther we look, the older the light we see, and there's a limit to how far back we can gaze. The cosmic horizon marks the boundary of our observational reach. But what lies beyond? Galaxies, perhaps? But we're in the dark. It's like peering into the next room without a flashlight. The universe holds its secrets close, just beyond our cosmic grasp.
Now, let's break free from the notion of an edge. Picture the universe as an ever-expanding fabric without boundaries, of what we call the spatial infinity. It's a bit mind-bending, isn't it? No walls, no edges, just an endless expanse. To explain this vastness, scientists propose cosmic inflation, an explosive expansion in the universe's early moments soon after its birth. It's like the universe took a deep breath and expanded faster than the speed of light. This could be the reason for the vast, uniform cosmos we observe today.
Honestly, there is nothing in our current understanding of physics that suggests the existence or even possibility of the sort of boundary you're thinking of. One of the basic principles in cosmology is, funnily enough, the cosmological principle. This states that when you look on large enough scales, like intergalactic scales, the universe is everywhere, homogeneous and isotropic. That means it looks basically the same in every part and in every direction. Obviously, we can't explicitly check whether or not this is true in the entire universe, but it holds up really well wherever we are able to check. And theory we develop assuming the cosmological principle tends to work very well.
We were told all of our lives that there's a boundary for everything, but that concept doesn't apply here. The universe having an edge would be a clear violation of the cosmological principle. Adding that to the fact that we don't know of anything that would cause there to be such a boundary, and no reason to suspect such a boundary even makes sense, we tend to assume that there is no such edge. Either the universe is infinite or else it is finite and closed, looping back in on itself. Current evidence supports it being flat and infinite, but this is not definite yet.
Well, to tailor down our argument, following reasoning go in line when we talk about whether there is an edge to the universe. Number one, the term edge can be misleading. It's not a physical boundary, but rather a limit to our observational capabilities. Beyond the observable universe, there may be more galaxies and structures, but we cannot directly observe them. Two, some cosmological models suggest that the universe could be spatially infinite, meaning it goes on forever without a distinct boundary or edge. In this scenario, the universe would be infinite in extent. 3. The multiverse hypothesis, which proposes that our universe is just one of many universes, formed due to explosions even after the Big Bang. Each universe within the multiverse could have different physical laws, constants, and properties. Various models of the multiverse include the inflationary multiverse, where different regions of space undergo rapid inflation, creating bubble universes, and the string theory landscape, where the multitude of possible vacuum states could correspond to different universes. Quantum physics also plays a role in some discussions about the nature of the universe. Quantum fluctuations at extremely small scales could give rise to the formation of different regions with distinct characteristics.
As we wrap up our session, remember that the universe continues to let out its secrets. Dark matter, dark energy, and ongoing missions are pushing the boundaries of our knowledge. What lies at the edge of the universe? It's a question that led us gazing at the stars, waiting for the next cosmic revelation.